Alright, so in this video we're going to briefly talk about when do we use the law of sines. And then we'll also do an example. Basically, when do we use the law of sines? Well, first of all, what do we use it for? We use it for solving triangles. So remember, a few videos before this one we talked about solving right triangles. And what does it mean to solve a triangle? Well, it means you're given some information about a triangle, some of the sides, some of the angles, and you have to use the given information and some functions from trig to find the missing sides and missing angles. So we've done that with right triangles, but now the law of sines actually allows us to do that with more general triangles. So we can do that with acute triangles and obtuse triangles also now. So now the law of sines won't always work, and if the law of sines won't work, then we'll have to do either the law of cosines or actually maybe we just won't have enough information. But anyway, so when can the law of sines be used? So if you're given, let's say we have a triangle here, and if you're given information about one of the sides and the angles right next to it, okay, so in other words, two angles and the side in between them, so that's an ASA triangle, okay, angle, side, angle. If you have a triangle like that, you can use the law of sines to get this side, and this angle here, okay? So, well actually you can get this angle just from the fact that there's 180 degrees in a triangle and you know these two angles, so you can get this angle right away. But the law of sines can be used to get this side and this side, okay? So for ASA triangles, you can use the law of sines. What else? For, let's say you're given, so we have another triangle. By the way, I'm kind of drawing acute triangles here, but whether they're acute or obtuse, it doesn't matter. So if you have an ASA acute triangle or an ASA obtuse triangle, it'll work. So ASA, it also works if you have two angles, if you're given two angles, and not this side, but really either other side. So if you're given this side or this side. So basically, in general, you can use the law of sines if you're given two angles and any side. Okay, so this side angle, angle, so this would be side angle, angle, or you can think of it as angle, angle, side. So SAA or AAS triangle. So ASA, SAA, AAS, these two things are really the same type of thing here, these two. And then here, so again, just to recap real quick, two angles and either side, the side in between them, or either of these other two sides out here, okay? And then the third type, if you're given two of the sides and one of the angles that's not in between them, so that would be something like this. So let's say you're given this side and this side, but not this angle, okay, not this angle, but either this angle or this angle. So this would be side, side, angle, or angle, side, side, so like an AS triangle, but most people don't really call it that, so we just stick with SSA. But anyway, if you're given two sides and either this angle or this angle, okay, so in other words, not the included angle, not the angle between them, then you can use the law of sines. Now the problem with this is this case right here leads to what's called the ambiguous case, and we will talk about that in a later video. But for now, let's do an example with one of these two, and then we'll talk about, we'll do some more examples in the upcoming videos, and then eventually we will cover the ambiguous case. But for now, just know that the ambiguous case can only come from SSA, and we will talk about that in a later video. Okay, so for now, let's see an example. And again, if you have something else that's not one of those cases, then you have to use the law of cosines, or just nothing will work if you're not given enough information. But let's go ahead and do an example. So let's say we have example 1, and we want to solve triangle ABC given angle A equals 64 degrees, angle B equals 82 degrees, and side B equals 14. Okay. And let's say we just want to round to the nearest hundredth, so I'm not going to spend time writing that, but let's round to the nearest hundredth, so 2 decimal places. Okay, so let's go ahead and get started. Okay, now notice we have two angles, so right away we can just get the third angle. So when dealing with the law of sines, it's probably best to get the third angle or at least have two angles before you draw a picture. So actually we have two angles now, so let's just go ahead and draw a picture. So let's see, kind of sort of something like this. Not to scale, my pictures are almost never to scale. Here's angle B, 82 degrees. This, I guess, can be angle A, 64 degrees, and this could be angle C, which is what we need to find out. And also side little b is across from angle big B. That's the convention that we go with, so that's 14. Here's side little c, here's side little a. Okay. So what kind of triangle is this? It's angle, angle, side. Okay, so this is an AAS triangle, angle, angle, side, or SAA, side, angle, angle. Okay. So that's, it's a triangle like this, so we can use the law of sine, so that's good. Okay, so let's go ahead and do that. Well, first, let's just get this angle here. So A plus B plus C equals 180 degrees. We know A and we know B, so we have 64 degrees plus 82 degrees plus C equals 180 degrees. 64 plus 82 is 146, so this is 146 degrees plus C equals 180 degrees. So then subtract 146 degrees from both sides and we get C equals exactly 34 degrees. Okay, so that's great. Now we have this angle in here, 34 degrees. Okay, now we need to get little a and little c, and we can use the law of sine to do that. So let's go ahead and do this. Let's say little a over sine of capital A equals little b over sine of capital B. So remember, the law of sine comes in a couple different forms. You can write it like this or with the reciprocals. It's going to be more useful to us like this because we're trying to find a, little a. So it's better to have little a in the numerator. So multiply both sides by sine of a, and then we get a equals b over sine big B times sine of capital A. Okay. Now we know little b, we know big B, we know capital A. Okay. So let's go ahead and just toss all that stuff into there. So then what this tells us is A equals, little b is 14, sine of big B is 82, so this is sine of 82 degrees. And then we're multiplying by the sine of A, and capital A is 64 degrees. Okay. So then A is approximately, so now we have to toss this into our calculator and see what we get. So let's go ahead and zoom in here. So we have 14 over sine of 82 degrees. Make sure we're in degree mode also. So 14 divided by the sine of 82 degrees. And then we're multiplying by the sine of 64 degrees. So that's about, rounding to the nearest hundredth, so that's about 12.71. So let's zoom out a little bit. Okay, so A is about 12.71. And we weren't really given any units, so we could write the word units, or let's just do nothing. Okay, now we have little a, now we just need to get little c, and we'll get it exactly the same way, just using the law of sines. And we mentioned before in earlier videos with solving triangles, we really should not use an approximation to get another value. So if we can avoid using an approximation, let's avoid it. And the reason is, if you use an approximation, 'cause remember we rounded to 2 decimals, if you use an approximation to get another value, then that other value might be inaccurate, and we don't really want to do that. So what we're just going to do is actually this exact same thing, but with c's instead of a's. So we're going to have c over sine capital C equals little b over sine of big B. Okay, so multiply both sides by sine of c, and we get c equals b over sine of B times sine of capital C. Now we know little b and big C, so let's just toss all that stuff into here, and then we get little c equals 14 over sine of 82 degrees, and then we multiply by the sine of capital C, and capital C we found earlier is 34 degrees. So what's nice is this is, even though this is a value we found, it's an exact value and not an approximation, so that's really nice. So this is sine of 34 degrees here. Okay, now we can toss this into a calculator, and we're going to get c is approximately, let's see, so we want to do 14 over sine of 82 degrees times sine of 34 degrees. So let's zoom in here and see what that is. So 14 over sine of 82, we already have that, and we want to multiply by the sine of 34 degrees, so we only had to change that one thing, that's nice. And this is approximately equal to, whoops, 7.91-ish. Okay, so we'll zoom back out. Okay, so C is approximately 7.91. Okay, and that's pretty much it for this problem. So that was a brief explanation of when we can use the law of sines and an example of using it for an AAS or an SAA triangle, two angles and a side that's not in between them. Okay, so that's, and again, here are the answers, and that's it for example 1.